Hello everyone, myself Jis Joseph and my team members Anu Somrazanke, Elvin Aloysius and Gladwin Biju. Today we are here with you for the presentation of safety monitoring system for passenger boats. Our project was guided by Ms. Sumida Joseph, Assistant Professor of Department EZA, SACET, and moving to the these are the contents that we have to discuss about today. And first one is mission statement, objectives, target uses, block diagram, working, circle diagram of the system, and PCP, flowchart, use case diagram of the product, and work plan, result, conclusion, reference, and achievements. These all are seen in next slides. Moving to the next slide, the mission statement of project, and we are ready to develop and deploy an innovative and cost-effective safety monitoring system for boats, and that could communicate with emergency authorities in case of any accidents using NVAGA 328P and GPS, GSM modules, and various kind of sensors. Next one is the objectives, and the main objective of our project was based on alert concerned authorities to give a proper alert notification to the people on the boat as well as the concerned emergency authorities in case of any accident or if it says safety limits and measures. And second one is to that the make sure that the boat doesn't exceed the maximum capacity or weight distribution as well as the speed limit. And third one is to ensure that the boat is traveling with proper orientation with the water. The purpose orientation is essential for safe and efficient uh, boating. And the final one is that to ensure the safety of people while traveling on a boat, and by developing a safety monitoring system that can be uh, implemented in 8 type of ocean crafts. And moving to the target uses, and first one is boat owners and operators, where the individuals who are responsible for the safety of the vessels and the passengers. And the second one is that search and rescue teams. These teams rely on the safety monitoring system to locate and assist distressed waters and vessels. And third one is the recreational waters. The individuals who enjoy boating for leisure by using safety monitoring system to enhance their safety while on the water. And the fourth one is the fleet managers. The companies with fleets of boats such as passenger ferries, etc., use safety monitoring system to ensure the safety of their assets and personnel. And moving to the customer requirement, when we conduct a real-time real-time sessions with um, board masters and different kind of station masters, while them addressing the different customer requirement. These are the different kind of customer requirements they addresses. And first one is the real-time GPS tracking. This allows boat owners or the station masters to see the vessel's location at any time, um, which is crucial in case of emergency or if the boat drift, of course. And the second one is environmental monitoring. Monitoring features like water level, smoke, carbon monoxide detection, and the extreme temperature readings that can help prevent fire and other emergencies, and accident or different kind of emergency situations. And third one is ease of installation and use. Whenever a system to be designed, the system should be user friendly or easy to install, especially for the non-technical boat owners. And the next one is the durability and the stability. As a safety system, it needs to be waterproof, corrosion resistant, and the function for rescue. next one is the battery life and power consumption of the system. The system should have a long battery life or efficient power usage to avoid the draining board's battery. The scalability and customization. Some customers might desire a system that can be expanded with the additional sensors or features as their needs evolve. And the next one is the remote camera access. The video feeds or the recorded footage can allow bot owners to check on the vessel remotely. And engine monitoring was the next customer requirement. The customer may want to monitor engine performance parameters like temperature, oil pressure, and RPM to identify potential problems before they become critical. And the final one is the automatic collision detection. The system uh, can detect an imminent collision and trigger alarms or corrective actions. For the log level functioning, over to you, Anu Somarajan.
So move on to the basic block diagram of our system. So this is the block diagram. So the main power unit, main processing unit is the Atmega 328P on the left side. You can see the emergency button, MPU 650 and MPU 650 gyroscope and Neo 6 and GPS module. These are the input giving components, and on the outside, on the right side, we keep the output to a 16:2 LCD display and SIM 800 GSM module and erasure. So the GSM module transmit the instant coordinates of our system to a Firebase database, and then we display the coordinates on a web page. And we also use the GSM module to give the alert. So moving on to the working, so I can explain it with the help of the circuit diagram. So as I've already said, the main processing unit of our system is Atmega 328P, and all the components except a GSM module require 5-volt power supply. So we use a 12-volt adapter and then regulate it to a 5-volt using an LM7805 voltage regulator. And we are using a crystal oscillator that can provide 60 megahertz of frequency. And the GSM module alone needs about 4 volt, a maximum of 4 volt and 2 ampere. So we are using a buck converter to give a separate power supply to GSM module. And moving on, so this is the basic PCB layout. And moving on to the flowchart, so we begin by setting the GPIO pins, and then we read the pitch angle from the MPU 650 gyroscope module, and then we calculate the inclination angle. And if the angle is greater than 35 degrees, we read the GPS data and send the current location with an alerting message to the concerned authorities. And after that, we read the initial GPS data and upload it to a Firebase database and display it in the website. So the emergency button also follows the same procedure. And
now coming to the sequence diagram of our project. When the bot operator starts the bot, the system will read all the sensor data. First of all, it will read the data from the gyroscope. If the inclination is greater than 20 degrees, it will alert the passengers first and then send the message to the authorities. If the emergency button is pressed, it will alert the passengers and send a message to the authorities. Also, the real-time location is uploaded in the database and it can be accessed in the web page. So the main components used are, first one is MBU 6050. The MBU 6050 module uses the popular MBU 6050 sensor, which includes both 3-axis accelerometer and a 3-axis gyroscope. The sensor can be interfaced through a I2C connection which allows an easy and direct interface between the sensor and a microcontroller. The next component used is GPS module. It has a 5 Hz position update rate. Then the operation temperature ranges from -40 to 85 degrees Celsius. It has a EEPROM to save configuration settings, and it has a rechargeable battery for backup. Supply voltage is 3.3 volt. It is configurable from 4800 baud rate to 1,15,200 baud rates, and the default baud rate is 9600. The next component is SIM 800L GSM module. It supports quad band GSM and GPRS network. This breakout board is perfect for application where size and cost is a constraint. SIM 800L GSM module also supports quad band, which means that it can work anywhere in the world. So using this module, we can send text messages, make or receive phone calls, and connect to the internet through GPRS. The main component of our project is Atmega 328P. It is an 8-bit microcontroller. Its features include high performance and low power design. Its memory includes 32 KB of programmable flash, 1 KB of EEPROM, 2 KB of static RAM, and 10,000 write and erase cycles for flash, and 1 lakh for EEPROM. So its operating voltage is 1.8 to 5.5 volt. So it has a low power consumption mode at 1.8 volt, 1 MHz and 25 degrees Celsius. So these are the tools that we used for our project. Arduino IDE we used for programming the microcontroller. Then Visual Paradigm Online we used for making the use case diagram. ECEDA we used for making the circuit diagram as well as the PCB. And we did our documentation part using the LaTeX.
In our use case diagram, a board mother starts the board. The device will initialize and then it will send a signal to the processing unit. The processing unit continuously check for the parameters based on the sensors we are using in the system, and that will be send the parameters to a real-time database as a value. Then it will create a report that can be accessed for station master. If the passenger feels any discomfort while traveling the boat, he can simply press the emergency button. That will create an emergency alarm or alert to the boat master. Then it will send the signal to the processing unit, and that will check the parameters, and it will send to the real-time database, and there will be generating a report that can be viewed by the station master. Moving to the next slide, we have our target specifications. And next slide, we have need metric matrices. And the next one is a bill of materials. A total cost of rupees 1660 rupees. This is our work plan. We started our phase 2 of project on 22 Jan 2024, and the final documentation and presentation
done in 1st April 2024. This is our result. In the first figure, the C programming used in Arduino IDE, and the other two pictures was our breadboard implementation of our project. This is our use casing. This is our products looks like. And the next one is the conclusion. This system is useful providing alerting notification to the people traveling in the boat as well as the authorities so that they can take precaution to avoid accident, saving the life of people and preventing further distraction. And at the same time, in case of any accident, it automatically notifies the emergency services, such as a huge time lag in between can be avoided. So far, we have created the necessary diagram and done the simulation of the hardware part, and this is our references. These are achievements. We are secured third place in paper presentation contested at APJ Abdul Kalam University TechFest 2024. The next one is the actively participate in Smart Indian Hackathon on 2024-23. Course attempted embedded for beginners organized by NIELIT and VLSI for beginners organized by NIELIT, VLSI system on chip designing, VLSI designing using Verilog HDL, and thank you.